Let's look at problems 8 and 9 together here in the same video. They're really very similar probability type of problems. Problem 8 says, a die is rolled. Find the probability that an even number or a number greater than 4 will be rolled. So we're going to roll one die. We want to know what's the probability that we get an even number or we get a number greater than 4. Well, now, here's a situation where we have to be careful. Is there any overlap between an even number and numbers greater than 4 on a single die? And the answer is yes, there is overlap. The number of outcomes is 6. If you're rolling one die, there are 6 faces. There are 6 total outcomes. How many of them would be even? Well, that would be 2, 4, and 6. So that's 3 numbers that are even. How many of the numbers are greater than 4? Well, 2 of the numbers are greater than 4, 5 and 6. But are any of the even numbers greater than 4? Yes, one of them, 6. So we have to remember to subtract that out so we haven't double counted it. In fact, you notice as I spoke them, I double counted them. The even ones, 2, 4, 6. The numbers greater than 4, 5 and 6. I can't double count that, so I've got to subtract 1. So that gives us a probability of 3 plus 2 is 5, minus 1 is 4, a probability of 4/6, which is what? 2/3 or 0.667. So we would expect that 2/3 of the time we would be able to roll an even or a number greater than 4. Now let's look at the other situation. Problem 9, and see how it's a similar type of probability problem. It says a single card is picked from a deck of 52 playing cards. All right, so now we're picking a single card from out of the standard deck of 52 cards. Find the probability that it will be a king or a spade. So we want to figure the probability that we would get a king or a spade when we pick that one card out of 52. And so there are 52 outcomes, aren't there? Again, keep it simple when you're only picking one thing. There are 52 cards. If you're picking one, there are 52 possible outcomes, 52 possible ways you could choose that card, 52 possible results. And we want to know what's the probability of a king or a spade. Well, how many kings are there? 4. King of hearts, king of diamonds, king of clubs, king of spades. So there are 4 kings plus how many spades? Well, there are 13 cards in each suit. Spades is one of our suits. Do you have any overlap? Yes, we do. The overlap is the king of spades. So we'll have to subtract that out so that we're not double counting it. And that gives us what? 13 and 4 is 17, minus 1 is 16. So we'd have 16 over 52, which reduces to what? 4/13, if I did my division correctly. Yeah, both those are divisible by 4. And whatever that would be is a decimal. So the probability that you could get a king or a spade would be 4 out of 13. So if you drew one at a time and replaced them, if you drew the card 13 times, you would expect theoretically that 4 of those times you'd get a king or a spade. Now, does that mean you're guaranteed to get that? No. Because remember, as we saw in some of our experiments in class, that empirical or the experienced probability is not always the same as the theoretical probability. And it takes many trials of that event, of that experiment, to have the empirical, the experienced probability come into line with theoretical probability.